Yeah, that's okay. So, hello, Arush and Vasu. I'm a BTech graduate from IIT Guwahati. As already said, I am Shubham Gaurav, and I have been with Test Flipkart for the last 2 years, and I'm a physics faculty for Test Flipkart. So, we'll be discussing this. So, one of you is in 12th, and was one of you is in 11th, right? Which one is in 11th?
from 11th.
Okay, so Arush is in 12th, right? Anyway, we'll start together. So, what we'll be doing is starting with the syllabus itself, and we'll be starting with the first chapter that is called scalars and vectors. And what I would like from both of you is be very interactive, try to answer whatever you can. It's not really necessary to answer always correct, it's just necessary to interact and give me what you're getting or what you're understanding. That's the that's one of the best way to let me know that you are getting it correctly or not. If it is otherwise, I will just redirect my approach in different way and let you know how to understand this, because it's a very important aspect that you interact with the teacher. Otherwise, I will have no idea whether you are getting it or not. And that's the whole point of this session, that you get it and you get a good rank in this JEE exam, right? So with that, we will be starting with the session. Let me share my screen. Okay. So scalars and vectors. Have you heard of these terms? Any of you?
Yes, sir.
Okay. If not, let me tell you. Anything in our physical world, we try to measure it, right? Measuring is one of the best ways to be consistent. Like, let's say I have this any object. Then, in order to describe what this object is, without even giving the object, one of the best ways to say is that there is an object having this much length and this much width and maybe this much height and maybe this much mass. If you tell, or you can tell the dimensions that this is a cylindrical object or a cubical object, things like that. So what I'm trying to say is quantification is the best way to communicate better regarding one of the things. If I say that something is 10 kilo in mass, it is 10 kilo, irrespective of what the person is or what the other person, where the person belongs to, in which country is the person belonging to. 10 kg will remain the same. So measuring things is a very, very important thing. Now, while measuring things, we have, let's say I have any physical quantity that can be measured. Of course, not every quantity can be measured, or not everything can be measured. For example, our feelings can't be measured, that I'm this amount of happiness, or uh, there are several parameters for our emotions, or very much subjective, right? So there are only few specific parameters that are called physical parameters that can be quantified. Quantified means measure it. You are able to measure it. So physical parameters. And if I want to further go into it, these can be divided into two different components or two different types, based on whether this definition that I'm giving it has a direction or not. For example, there is a mass of 1 kg. There is an object of mass 1 kg. Do you think this 1 kg has any direction, or giving it a direction, does it really add to the information of 1 kg? Vasu, any idea?
No, sir.
No. But whenever I'm saying that this car is there and it is moving at the rate of 10 kilometer per hour, then giving it a direction actually adds to the information to where it is going, right? This car going in at 10 kilometer per hour towards north is different from the situation when this same car moving at the same speed, 10 kilometer per hour, is moving towards, let's say, west. These two are very different situations, right? So this direction was a very important parameter in this one. So based on, so what we discussed here was, there could be, let's say this is called velocity. There could be some types of parameters that can have meaning in itself without even mentioning the direction, or adding direction into it is kind of pointless. For example, mass or volume is kind of independent of direction, right? Even if you give it a direction, that will be kind of pointless. But there are some parameters in which it is essential to give it a direction. For example, if you're applying a force, let's say you're pushing it, there is a object of mass, let's say 1 kg, and you're pushing it with, let's say, 10 newton. Is it really important to tell me that in which direction am I pushing it? Is it vital information in this case? What do you think?
Oh no, sir.
Is it not really important that in which direction am I pushing it? It is, right, because this condition is different from this condition. I mean, if you apply 10 newton in the rightward direction, it will push the body towards right. But if you apply the same 10 newton in the from the upward direction, then it will go down south, right?
Yes, yes.
Newton, or what is the 10 newton? It is the force. So this force has the requirement of direction. Can I say this? Did you get the distinction between these parameters? One which needs direction for its definition, and one which does not need any direction for its definition. Did you get the distinction between them?
Yes, sir.
Arush, you're not kind of responding. What happened? Arush, are you able to hear me? I don't think your mic is enabled. Maybe you can, from the left hand side of the this thing, Google Meet, there is an option to allow the mic as well as camera. You can try that. In the meanwhile, let me go ahead. Um, so based on the whether direction is there or not, the, yes, yeah, Vasu, try. Sorry, Arush, are you able to speak now?
Can you hear me?
Yes, perfect. So now moving ahead, whether direction is there in the physical parameter or not, I can divide physical parameter itself into two different types. One is called scalar, which is independent of direction, where giving it a direction is kind of pointless. For example, a 1 kg mass does not have any direction, right? Because mass is amount of matter inside a particular body. It does not have any direction, or it does not signify any direction, independent of direction. While there could be another type of physical parameter that could be called vector quantities. Those are dependent on direction. Did you get the distinction between scalar quantities and vector quantities?
Scalar
Yes.
has magnitude only, and vector
We'll
has
come to that. We'll come to that. The magnitude part, we'll come to that. Don't jump. Okay.
magnitude and direction.
We'll come to that. We'll be discussing about both magnitudes, units, everything. But I was just talking about this distinction into two different types that is purely based on direction. So we discussed direction first. All right. Now we will come to something called the magnitude that as I suggested. Now there is a block which you are pushing with some force, and you have another friend which is also pushing in the same direction. But does that necessarily have to be the same force? What do you think? If you both are pushing in the same direction, will the body move in the same manner for both of you, or could there be any difference? What do you think? It could be that this person is pushing it with 10 newtons while you are pushing with 15 newtons. Both have the same direction towards the right, but still you will have different results. So what I can say is force not only depends on direction, but it depends on the this quantity as well, the numerical value. And this numerical value that I have is called first magnitude, and this magnitude includes the 10 Newton that I'm saying. Now, this magnitude can also be divided into two different components, which is numerical value and the unit. In this 10 Newton, what's the numerical value that I have? Any idea?
10.
Yes, 10 is the numerical value here. And what's the unit?
Newton.
Yes, it's Newton. So both are important here. Only assigning a numerical value into a vector or a scalar quantity does not completely define it. Let's say I have this thing and I want to define the length. Only saying it is 1 will not completely define it. You will have to say whether it is 1 centimeter, 1 meter. There are several different units for length itself, right? And they all have different meanings. So only giving you value of 1 is not going to be enough. You will also need something called unit. Unit is a reference thing. For example, 1 centimeter is defined for the whole world to be fixed of this much. This is 1 centimeter for each and every person on earth. That is why we have defined it. So that it is a constant value with which we can compare other parameters, so that we are not, for example, I have this object, and if I want to measure it, measuring it in a fixed reference, for example, centimeter or meter, everybody will get the same answer. But if some person, let's say, is having another unit, let's say it is measuring in another unit, let's say inch, and this person does not have any idea, this person which is measuring in centimeter does not have any idea of the inch, then these two are not, will not be able to communicate with each other what's the length of this object. So it is very important to have the same reference for getting an exact idea of the physical parameter. Is this okay, students?
Yes. Yes.
Okay. So the scalar quantity will have only magnitude, because magnitude includes numerical value and both unit. So scalar quantities will only have numerical value and the unit. Now, coming to the vector quantity, they will have magnitude as well as direction, plus direction. So if you want to, let's say, define the velocity, you will not just say that it is moving at 10 kilometer per hour. You will also have to give it a definition that it is 10 kilometer per hour towards some direction, towards, let's say, north. Then this whole thing becomes a representation of the velocity. Only giving you 10 kilometer per hour is not going to be sufficient for the velocity. Am I clear? Why
Yes,
direction
sir.
is important for vector quantities? Yeah, what was the question? Somebody was trying to say something. I don't know. Okay,
No.
okay. Moving ahead. So the basic difference between scalar and vector is that scalar quantities have only magnitude, which includes both numerical values and the unit, and the vector quantities will have both magnitude and direction. So does that mean that vector quantities will also have numerical values and unit? Does it mean that?
Yes, sir.
Of course, because magnitude includes the numerical value and the unit. Okay. Now, if all that is clear, can you give me some examples for scalar quantities based on the these properties of scalar quantities? Can you give me an example?
So work.
Mm, Work. Okay, we are starting with some complicated or rather not so simple uh, examples. Anyway, can you give me more simple examples? Because it's better to start with the easy, simple examples. So,
Time.
yes, very good.
Time. Yeah.
What is that? Can I say mass?
Nothing. Yes.
Maybe volume. And if I have mass and volume, can I say density? Does density have any direction? Of course not. Right?
Energy.
Great. Energy is the most fundamental part of scalar quantities because it is essentially not having any reaction. Now, you get the idea. What are exactly scalar quantities? Now, give me an example of vector quantities, which has both
Force.
magnitude and direction. Force and maybe a few more.
Velocity. No.
Mhm. It will have. Is let me ask a question. Is there something very close to or very similar to velocity which is not a vector quantity?
Speed.
Yes, because speed, although while an object has some speed, it also has a direction. But while measuring speed, we neglect the direction. We only measure with what speed or with what kilometer per hour or meter per second it is traveling. We deliberately ignore the direction. That is why it is scalar. Okay. Now, maybe one more example for vector quantity, guys.
Acceleration.
Nice. So that's more or less the idea that I wanted to impart. Now, let me discuss some basic representation or graphical representation of scalars, or sorry, vectors. We will be mostly discussing about vectors here because scalar is something that you are pretty much aware about, right? Something that does not have any direction, time, mass, all that. It's pretty easy to understand with what the knowledge that you have till now in your previous classes. But vector quantities are certainly new to you. So that is why in this chapter we will be discussing mostly about vector quantities. Now, uh, some properties, some basic properties of vector quantities that we'll be discussing. First, graphical representation. It means how do we represent them? Now, graphically, you guys are well aware of the graph things, right? Drawing a graph, how to draw a graph, everything like that, right? Okay. If that is okay, then
Yes, sir.
uh, I have a vector pointing towards, let's say, northeast, having 10 units. So 10 units towards northeast. How I will represent this vector graphically is by drawing a line of 10 units of 10 units towards northeast. So what's the direction of northeast? It is this one, right? So the length of this thing is going to be 10 units, and this arrowhead, I will always point this arrowhead towards the direction, not opposite, because I have this option to also maybe uh, add the arrowhead here, right? But that is not I'll do, because that will point the direction towards southwest. This arrowhead represents the direction of the vector, and this length of the arrow represents the magnitude. So with this representation, have we taken care both of magnitude and direction? What do you think? Hello.
Yes, sir.
Is there any confusion with what we have discussed just now about the graphical representation?
No.
Okay. Then, how do we represent it in algebraic form? Let's say I am writing an equation and I want to write something which is vector in nature. algebraic representation. It essentially means how do we denote them. So any term, let's say I used to have any quantity of any variable a. Now, in order to tell you, or in order to uh, maybe imply that this a is a vector quantity, what you need to do is put a arrow on the head. This arrow on the head is a universal signal that this a quantity, a is a vector quantity. This is the meaning. Is this clear? And
Yes, sir.
this arrowhead that I'm presenting here will always be towards the right. Do not get confused that if my vector is towards the north, then I will represent it with something like this. No, this is just a representation that this is a vector quantity. It is not telling you in which direction is the this a vector, anything like that. It is just a denotation. For example, uh, I have this denotation L for length, right? For length. Does this give you any value of length? Of course not. This L just represents that the number I want to represent by L is just a length. In the same manner, what this A arrow would represent this, or would represent is that A is a vector quantity. Just that. It does not tell you in which direction it is. It does not tell you what's the magnitude. It just tells you that A is a vector quantity. Is it all right till now?
Yes, sir. Sir.
Okay.
Yes.
Moving ahead, if I want only the magnitude of a vector, how do I represent it? The way I represent it
Um,
is with a mod. Do you guys are you guys aware of this function mod in mathematics?
yes, sir.
Yes. It essentially takes any quantity and makes it positive. For example, if you feed it -3, it just gives you 3. If you feed it 3, it still feeds you 3. So it just gives you the numerical value. It ignores the negative or positive. In the same manner, if you apply a mod over any vector quantity, it just gives you the magnitude. It ignores the direction associated with the vector quantity. All right. But this representation does not say that A is getting converted into a scalar quantity. No, it just tells you that I'm only concerned about the magnitude of this vector quantity. This remains a vector quantity, but I'm only concerned about the magnitude. Is it okay, guys?
Yes, sir.
Okay. Coming to the fourth one, this is where it gets interesting. Angle between the vectors. So, in this chapter, what we will be doing is mostly interaction of multiple vectors. And if you have interaction of multiple vectors, it is one of the most vital information to get to know about the angle between these vectors. What this angle, or what these two vectors make angle between them. For example, or let me start with this thing. If I have a vector of 5 unit pointing towards northeast, just assume there is a vector A vector is 5 units towards northeast. Towards northeast. Is this representation okay that I've drawn here?
Yes, sir.
Now, if I draw something like this, will that also be okay? Of 5 units pointing in the direction of northeast? Could this be also graphical representation of the same vector? What do you think? Any idea? To check it,
So
to check,
it
yes,
could
was
be if
It could be.
The length of the arrow is the same,
And
and the
what's
angle.
the, yeah, direction. The two basic or the two
Yeah.
only important components inside a vector is magnitude and direction. If both are the same for two different vectors, those two vectors are going to be exactly the same. So checking this one, it has a magnitude of 5, it is pointing towards northeast, so this will also be a representation of the same vector, right? What this essentially tells you is, if I have a graphical representation, if I move it in any direction by keeping the direction same, let's say I have this vector representation in this direction, my palm. If I move it like this or this or this or this, it doesn't change anything. It still remains the graphical representation of the same vector. Do you agree? What do you
Yes,
think?
sir.
Yes, because the length remains the same, the direction remains the same. Now, I wanted this to get into your mind before we start with the angle of the vectors, angle between the vectors. Let's say I have two different vectors. There is one vector and this is one vector. This is pointing towards northeast and this is pointing towards east. Maybe it can have a unit of 2 unit, and maybe it has 3 units. What I need to find essentially is the angle between the two vectors. How will I do that? There's a rule for that. The rule is that join the tails. Join the tails first of all. And how do I join the tail? Is it like I rotate the vector, make it something like this? Is it how I do that? What do you think? Take a guess.
No, sir.
Why?
So I think you can move the
No, no, no.
it.
Tell
You
me the
can move
answer
it
of why.
parallelly.
Why I can't do that.
It will change the direction.
Exactly. It will change the direction and essentially it will change the vector itself. It will not remain the same vector. So what I can do is maybe translate it further towards the second vector and make it join like this. All right? 2 unit. Now, a perfect northeast makes what angle with the horizontal? It's the exact value between or exact direction between north and east, right? So it should be making
45 degrees.
half of the 90-degree, right? 45-degree angle.
45 degrees.
So
Yeah.
if this is making horizontally 45-degree, it should also make 45-degree here because the second vector was essentially towards the horizontal, right? East direction. So this angle will be 45-degree here. Is it all right? How do we find a direction? Oh, sorry, angle between two vectors?
Yes, sir.
Yes, sir.
Just make their tails join and then find the angle between them. Okay, if that is clear, then let me ask a couple of questions. The question is, let's say I have this vector and I have this another vector. Um, all right, and now they are making an angle of 150-degree with each other. This is A vector, this is B vector. Then tell me what's the angle between A and B? Angle between A vector and B vector. Is the question clear?
Oh, uh, 210 degrees.
210 degrees. So the assumption that you took was, um, how did you do that? 360 minus 150, is that what you did?
Yes.
But why? Just see the rule. What's the first rule?
Join the tails. Yeah.
Did you do that?
No.
Do that now. Arush, any idea?
Hmm. A and B.
Yes. Vasu, any idea?
So no, sir.
No. Could you make the tails join? Can you translate it and make the tail join? Just do that. It's very important for you to try because, see,
Oh, sir, it's
uh,
30 degrees.
yes. The one thing that I want to share with you is that in the journey of JEE, no matter how many solutions that you see, no matter how many questions that you see the teacher solve, it will not change anything. The only thing that will change your rank or marks will how many questions you solved by yourself. So keep that in mind. It's very important. No. 30 degree, how did he say? Arush?
30 degree.
Yes. You just said 30 degree. So I'm asking where did you get the answer? How did you get it?
So, sir, B, and if you join the tails, they become parallel, and then you could
Okay.
say co-interior angles.
So what I do is basically translate it here. Something like that. And it will be like this, right?
Mm.
B vector. And now I have both the tails joined. That is exactly what I wanted. And the angle made between these two. Now, one question can still arise whether to take this angle or this angle. Isn't it natural question? Is it? It is right. You always take the value which is uh, lesser than or equal to 180 degree. Something greater than 180 degree is not what you're supposed to take. Okay? Is it fine? What you just said.
Yes, yes, sir.
So you'll take this angle. How to find this angle? If this is 150 degree that you have been given, and these are two parallel lines, then these two angles, this one and this one, should make a summation of 180 degree, right? X plus 150
Yes.
degree should be equal to 180 degree, and hence x is equal to 30 degree. Do I assume that you both have got it clear? How to find angles between the two vectors?
Yes, sir.
Yes, sir.
Then let me give you another question and see whether you have actually got it. Let's say I have this vector A and another vector, and I have joined the heads here, and they are making an angle of 45 degree. A vector and B vector. Can you tell me what's the angle between the A vector and B vector? Angle between A and B.
135 degrees.
Check again before jumping into the
Wait.
question answer.
Oh, wait, what's that? Say angle of A and B.
Angle between A and B. That's the question. I have arranged it like this, but that's not the that doesn't change the definition of angle between the two vectors, right? It's always the tails joined, isn't it? Any confusion, guys? Just do
So,
some.
wouldn't it
Yes.
still be 45 degrees?
The 45 degrees is the angle when both the heads have been joined together, and the angle made between the heads is 45 degree. Arrowheads.
So, between A and B.
We
A and B.
see. Let me explain the question again. There are two vectors A and B. All right, and I have arranged it together so that I have just tried to arrange it together so that their arrowheads are touching each other. Their heads are touching each other, and the angle made between the heads is 45 degree. Okay. Now you have to tell me the angle between the A vector and B vector. Is there still some confusion regarding the question, Arush?
No, sir.
Okay then. Any answer, Vasu?
I'm trying.
Just try to shift some vectors so that to in order to make the tails join, right? Because that's the only thing that you need for finding the angle between the vectors. Where could you shift it so that the tails are joined? And what will be the angle then?
45.
Still 45?
Yes.
How?
So if you shift it parallelly, you can
Hmm.
get alternate angles.
Exactly. Exactly what I wanted to hear. See, what you'll do is maybe shift a vector. You could do another way as well. A vector has been shifted to here. A vector. Now, this is the angle that I always wanted, right? That's the angle between the two tails. And aren't these lines and these lines parallel? They are, right? Because it's essentially the A vector line. And the angle made here should be equal to this one, alternate interior angle. All right. So this angle between A and B is equal to the same angle that was given in the question, 45 degree. Is it okay, guys?
Yes, sir.
All right. If that is okay. Yeah, Vasu, any question?
No, no, sir.
Okay. If you're not getting any of the parts, you can let me know any part of the. It's a basic rule of my class that whatever you're not getting it, just ask their ends itself. Do not accumulate it. Do not make it a burden on yourself. Just ask it there itself. It will be far more easier for both of us to sort it there itself. Okay. So moving ahead, uh, I would discuss several types of vectors. Types of vectors. The one most important type of vector that I want to introduce here is something called unit vector. It is going to be extremely, extremely important. I can't overemphasize how much this important this vector is. Unit vector. Can I take a guess what this unit means or what this unit might mean?
So one.
Yes. So this vector is something which has a magnitude of 1 of 1. Any vector which has a magnitude of 1 can be called a unit vector. Now, how many different unit vectors can I have based on this definition? What do you think? I can have infinite, right? One vector of one
Yes.
unit pointing here, one vector might be pointing here. Any direction I can point with one unit, that will be my one a unit vector, right? The representation for unit vector is, let's say A is a unit vector. Of course, it is a vector. I can still represent it with an arrow. What the what is written inside the box? What does that mean? That's my question. What does that mean? If you have any quantity, an arrow above it, what does that mean? What's the meaning of that thing?
It's a vector.
Yes. In the same manner, if I give it a cap, inverted cap, it means it is a unit vector. Okay? It's a representation of unit vectors. Is there any problem understanding this? So can I say
No, sir.
all unit vectors are vectors also?
Yes,
Of
sir.
course.
Yes, sir.
Of course.
Mm.
Okay. If all that is clear, then let me define some unit vectors. And one more thing, any unit vector, what should be this value?
One.
Of course, one. Because I'm only talking about magnitude. Let's ignore the direction. So I hope all this is clear. Now, one of the most famous unit vectors are, which direction do you think is the most important? Maybe which three directions do you think are the most important in any plane? Let's say I want to define any. Uh, have you heard of this term called Cartesian plane?
Yes, sir.
You must also have heard about the third dimension as well, the z axis, x axis, y axis, and the z axis as well. The way we represent z axis is this, but essentially, what you have to imagine is, if this is the plane, x and y, y is upwards and x is here, then z is going to be inside or outside the plane. That's the line I'm talking about. Is it understandable?
Yes, sir.
Z axis. Okay. So the line that is coming out of the plane is positive z axis. Do not get confused. The line getting inside the plane is negative z axis. Okay. Negative z, negative x, negative y. Is it all right?
Yes, sir.
Now, let me give you three different unit vectors. It is very obvious to say that a unit vector in this direction will be very, very important, because it will essentially define the direction itself. See, what's the use of a unit vector? What do you think? Can you take a guess? If I am defining a unit vector with such great detail, what should be the use of that? It defines directions, because in any vector we have magnitude as well as direction. But if you have fixed the direction, fixed the magnitude, the only variable stays in the vector is the direction, right?
Yes, sir.
So unit vector is a representation of directions only, because magnitude has been fixed equal to 1. So if I want to, let's say, let me give you the unit vectors here first, and then give you the rest of the detail on that. The unit vector in the x direction, unit vector in x axis or towards positive x axis, we call it I cap. Unit vector in positive y axis is called j cap, and the unit vector in positive z axis is called k cap. Can you remember these three names, I, j, and k? It is going to be very, very important. It will be used everywhere in physics, even in mathematics. All right.
Yes, sir.
So these are the three standard unit vectors that we should be taking care, because these will be used to define any vector that are there. Okay. So yeah, I was going to the detail of this, that it defines direction. Then the basic use of unit vector is that, let's say I want, what I want is a 10 unit vector, a unit vector, oh, sorry, a vector having 10 units as the magnitude towards x axis. Let's say I just want a vector a that is 10 units towards positive x axis. The way I will do that is simply 10 units, 10, and what's the representative of x axis? The unit vector towards x axis,
I cap.
I cap. So if I just write 10 I cap, what does that mean? It means,
Yeah.
what's the magnitude of this
It's
thing?
10
What's the
units
magnitude of all
in the
this?
positive x
Wh-
direction.
Yes. And what's the magnitude of this whole thing? It's
10?
only 10, because I cap has only magnitude of 1. So 10 multiplied by 1 is 10. So basically, the use of unit vectors is that you can just add, or you can just put whatever magnitude that you want, and you already have the representative of the direction, that is unit vector, and you have the whole vector with you. I have this a vector is equal to 10 I cap. Did you get the logic? Why we did all the this whole detail of unit vectors, guys?
Yes, sir. Yes, sir.
Okay. If that is clear, then um, can you give me another b vector which is 5 units towards, let's say, z axis, positive z axis? Then b vector is going to be what in ij and k terms? What should be that?
5K cap.
Yes, 5k cap. Let me ask you one more question before we move on to another topic. Is if c vector is something, uh, let's say 20 units towards minus y axis, what do you think? What should be c vector?
Minus 20 J cap.
Minus 20 j cap. Why? Why did you take minus 20? You should have taken 20, right? 20 is the unit, or 20 is the magnitude. Why is it minus 20?
So because mm,
Mhm.
J defines unit vector, and in the negative direction, it gets a
J
minus.
defines unit vector towards the positive y axis, but I wanted a unit vector towards the negative y axis. So what should be the unit vector towards negative y axis? If I have a vector like this, j cap, another vector in the opposite direction will be negative of that, right? So I need
Yes, sir.
not give another name to this downward vector. I can just use j cap and just put a minus there. It will represent the opposite of j cap, right? So that
Yes,
is
sir.
why what I did was 20 units minus j cap. So it was minus 20 j cap. Is it all right, Vasu?
Yes, sir.
Okay. If that is clear, then I guess we are ready to go ahead towards more of the other types of vector. Mostly we'll be dealing just with the uh, definitions, so that you are aware of what are different type of vectors. Now, equal vectors. When do you think will two vectors a and b equal? A vector is equal to b vector. Then what should be the condition? What do you think?
So the magnitude is the same,
And
the direction
is it same or different?
same.
Yes. So basically, vectors has two components: magnitude and direction. Both has to be same, so that these two vectors are the same. So both magnitude and direction should be the same for both of the vectors. If you have two vectors having same magnitude and same direction, those are called to be equal vectors. Now, let me give you another type of vector: parallel vectors. Take a guess. When can I say a vector is parallel to b vector?
When the direction is the same,
What about the magnitude?
the magnitude can differ.
Yes, can differ. It can be same, it can also be different. So Just the direction should be the same. Can I say equal vectors are also types of another type of parallel vectors?
Yes, sir.
Yes. Anti-parallel vectors. What do you think should be the condition? If two vectors are called to be anti-parallel,
So they are in different directions, like opposite directions to each other.
yes.
Magnitude can be the same or differ.
See, in mathematics, you have just straight lines. These straight lines, they do not have ends, or they do not have arrowheads. That is why you say that they are both parallel. But if I say there are two different vectors pointing, let's say, towards northeast and towards southwest, they are not parallel. They are anti-parallel actually. Vasu, did you get the logic? The distinction between what we call parallel in mathematics and physics. Okay, so direction opposite, just opposite, directly opposite. Not like if this vector is like this, another vector is like that, so almost opposite. It doesn't work like that. They have to be exactly opposite. So direction should be opposite. All right. Now, is there, yeah, maybe zero vector. As per the name suggests, what should be that?
A vector with no magnitude,
Yes, magnitude and is equal to zero. What about the direction?
it can have any direction.
Can it have any direction if the magnitude is zero?
Not really.
Because it is kind of pointless. If
Yeah.
it is just a single point, you cannot really have any direction, right? If the magnitude is zero, it does not have any meaning. It's kind of pointless. So direction is pointless or redundant or arbit would be best word to describe it. Now, I guess the most important types of vectors has been discussed. Any doubt till now, guys?
No, sir.
No, sir.
Okay, then. If that is clear, then we'll be moving ahead to something called addition of vectors. This is where your actually analytical physics starts. Problem solving things, addition of vectors. So, let's say I have two vectors, A vector and B vector. And I want to find the addition of these two vectors. C vector is equal to A vector plus B vector. I want to find a vector which is the addition of these two vectors. How could I do that? Now, in this thing, I have something called the parallelogram rule. Parallelogram law, which says that first of all, what was the first step in finding the angle between the vectors?
Joining the tails together.
Yes, that is exactly the first step here. Join the tails. Let's move A forward and make the tail of A join tail of B. Now, what you need to imagine here is a parallelogram with these two as the sides of this parallelogram. Can we get the parallel sides? Yes. Will that be the parallelogram? Having these two as the sides, A and B vector?
Yes, sir.
Okay. If that is okay, Then, uh, yes, then the addition of these two vectors will give you another vector, which will be the diagonal of this parallelogram. Now, this vector has, sorry, this parallelogram has two different diagonals, right? This one and this one. What you have to take is the diagonal from where these two actually meet, or from where the ends of these two vectors lie, to the opposite end. Are you able to visualize the green vector that I've drawn?
Yes, sir.
This vector is actually the addition of these two vectors, a vector plus b vector. Is it okay?
Yes, sir.
Yes, sir.
Okay. Uh, So join the tails, and the second step would be simply the diagonal from the common tail to opposite vertex of the parallelogram. Opposite vertex of parallelogram. Now, I have drawn this vector, but I have two options, right? I could point it towards this or point it towards this, isn't it? Right? Then what you need
Yes,
to
sir.
get is the direction will actually be, you have started from the common tail, right? You have started from the common tail of A and B. So that should remain as the
Yes.
tail of the addition of the vectors itself. And the opposite end will become the head. Okay? So
Yes, sir.
this addition C vector will have the same tail, will have the same tail as A and B. Same tail as A and B. I'm writing these down so that you know exactly whenever you get confused, because it's very easy to get confused whether to point it towards this direction or the opposite direction. So I'm writing these three down so that even if you get confused sometimes, you will see that you can see that, and you will be able to sort it out. Now all these are clear, right? Any problem?
No, sir.
Okay, if that is clear, can you quickly, on your whatever you have, a paper or your tab maybe, what you can do is, I'm drawing two different vectors, uh, a vector and b vector. What you need to do is make a vector which is equal to addition of these two vectors. Is the question clear?
Yes, sir.
Okay, just draw it on your notebook. I guess we are close to 1 hour. Maybe after discussion we'll end the session.
Okay, sir. Yeah, I'm done.
Could you just maybe show it if you have a paper?
Yep, I can. It's like this.
uh, the algorithm
Uh,
for the virtual background is clearing it out anyway. Where is it pointing to? Just tell me approximate
Let me
direction.
flash light in. Can you see it?
Not helping it, not
Sort of.
helping it. Leave it,
Okay,
leave it.
wait.
Just tell me the
Yeah.
inwards, what's the direction pointing it?
Um, it's pointing this way.
Towards northeast,
Yes, sir.
kind of. Vasu, could you do it? Any idea?
Sir, no, sir. Could you show, sir?
Yeah, I'll just show it how to do this. First of all, what you need to do is, uh, sorry, just a second, guys. Yes. So what you need to do is make the tails join, right? So what I'll do is make the tails join. B vector. Any problem now, Vasu? No.
No, no, sir.
Now imagine a parallelogram for which these two are the sides of the rectangle. Sorry, right sides of the parallelogram. Then this should be another parallel side, and this should be another parallel side. And where these two join is going to be, is it going to be the head of the vector or the tail of the vector? Where these two join,
So the head.
yes, and the tail will remain the same. So this vector is going to be addition of these two vectors, a vector plus b vector. Got it, Vasu?
Sir. Yes, sir.
All right. So I guess that is the time of for today. But we'll be continuing with this in the next session if we have any. All right. Any problem in today's discussion?
No, sir.
Okay then.